we had to take the tuk-tuks to this place, which is not recommended by any means if you prioritize your life expectancy over speed and convenience. Just on the side note. All right. Okay, I think we're ready. All right. So my name is Joanna. I'm the co-founder, CEO of SOON, Solana Optimics Network, and I'm joined here by my CTO co-founder, Andrew here. So here we wanted to talk about Decoupled SVM, why it's important, why we decided to build the first one, and just give you the overview of what it can do. So first, I wanted to be specific about the presentation today will be mostly technical because the audience here, are developers here. But let me start by let me shake it up a little bit. Let me start by asking questions. And if you consider yourself a Solana maxi, please raise your hand. There's like a single or two people here. Okay. Do you consider yourself you're an Ethereum ETH maxi? There's a few more hands, right? There's other people who probably don't consider themselves maxis at all, which I think I kind of fall into that camp. So the good news is you no longer have to choose your camps, right? We brought both Solana and Ethereum, the best of the two worlds together, with Solana being the execution layer and settles on top of Ethereum. So the idea is to use the high performance using parallel SVM, right? This is the underlying tech stack of Solana virtual machine, and the liquidity and user base, which obviously Ethereum boasts as the most highly adopted user ecosystem, right? So we can now, for the first time, bring them together. And for folks here, I think the one word that you can all agree on, regardless of your maxi camps, is we all want this holy grail, right? We all want to achieve mass adoption. So how do we get there? And who has done a good job to maybe get close to that? Because very clear that no one has actually done that yet. Otherwise, we'll have a lot bigger room than this. So I would say, by looking at our background, right? Me and Andrew have been working on L1, L2 ecosystem in the past. I had worked at OP and Optimism, and Andrew had worked in the Polkadot. So we have both EVM and LVM experience in the past, and it really became clear when we looked at the current landscape in the space. With Solana has been kind of considered as this innovation hub for developers, right? Where all the new primitives like meme coin and AI agent are being launched there, right, as new use cases, and then expanding to other ecosystems. So why is that the case? I think a lot of this has to do with the developer culture, right? Where on the EVM side, there's a lot of fragmentation of liquidity and the developers, and people just become grand farmers and hopping around. Whereas in the Solana side, folks actually stay through the cycles and build through these difficult times. So what we're trying to do is to bring this best part of Solana, which is again the top performance and the builder culture, to other L1s, right? So we're starting with Ethereum as a start, which is our SOON mainnet, right? That's the general purpose chain with the SVM rollup on top of Ethereum. And then we essentially, the underlying tech stack is what I consider as the most valuable, because we're the only team that's building an SVM stack. So this allows anybody to use it to spin up your own SVM rollup on your choice of L1 using your choice of DA. And then lastly, and this, by the way, can be used for app chain purposes, right? And then the last part is this interoperability feature, which basically ties everything together with the liquidity fragmentation issue, the solver for that, right? Because we have built the interoperability that's embedded in the sequencer, so it help with the native interop with all the SOON chains, as well as some of the L1s that we consider as the most popular ones, right? Like Solana and Town. We actually built the first asset bridge between Solana and Town. You guys should definitely check it out. I have a Telegram mini app at the end that you can just scan the QR code. So that's our vision, right? SAS. And the current status is we already launched the SOON testnet, right? So this is, again, the first decoupled SVM rollup. And then we have the InterSoon bridge, as I mentioned earlier, between Savannah and Tom, currently the asset bridge, right, currently live. And we're going to launch our mainnet by the end of the year. Next. So this is how we are able to accomplish 50 milliseconds block time and 30K TPS, right, by introducing this new modular approach to Ethereum and help grow the ecosystem Ethereum. So yeah, let's go back to Decoupled SVM, right? So with that overview, why did we pioneer this Decoupled SVM approach? By the way, we coined this concept, so I want to spend a couple minutes on what that actually means. So this is in contrast of fork SVM. So there are a few other SVM projects out there that are working on this forked approach, which means they just copy the consensus layer, the client side of Solana mainnet, which consists of like 30 to 50% of the transactions as voting transactions. So as an L2, you don't need a consensus layer, right? That's useless to us. So we figured out how to how to separate the execution layer from the consensus layer, and strip out those voting threads, those empty block space that's actually causing a lot of DA waste, and it's actually getting passed down to the users. If you look at some of our fellow teams that work on SVM projects, they are topping the DA charts, right, as #1 on the all-time high chart, but not knowing it's an inefficient approach that's actually causing a lot of cost to the users. And then the second thing is it really helped with the security of the chain, because we can introduce the fraud proof, right? We're using a ZK fraud proof on top of the rollup design. And lastly, we're also using the Decoupled SVM as a way to introduce this message bus concept, right? That is more prevalent in the Web 2 world, but people in Web 3 hasn't done that yet. So essentially, we're improving the TPS without doing this vertical approach, as people would say, but horizontal approach, right? So spreading the TPU, the transaction processing unit workload across multiple machines, and that will help with the TPS improvement as well as flexibility to rotate amongst multiple machines. Yeah, so this is a little bit more kind of a specific differences between the fork approach and decouple approach. I mean, the one thing I think that is important to take away is the fact that we are not only just looking at the challenging, like for the fraud proof, for instance, right? Not just challenging the correctness of the TPU itself, but actually looking at the derivation pipeline, and something that I know Andrew is going to go into details on. So yeah, let me pass on the mic to Andrew.
Okay. Before talking about the SVM, decoupled SVM, let's talk about the optimistic rollup. This is the architectural optimism. As you can see, the red part, op node and op get, they are the sequencer, so-called sequencer. Op node will subscribe the R1 block info and the deposit transaction. Make sure the package in each of the R2 block with the other R2 payload user transactions. The OP gas is the execution layer. The batch will comprise all the R2 user payload and send all the data into the DA layer. The proposer will intervally propose all the output routes, which include the state route, withdrawal route, R2 block hash into a settlement layer, say Ethereum. And the trust assumption is that if proposer writes a wrong state route, anybody can challenge it by using a fraud proof. So here's the optimistic rollup. And the gas client is not initially designed for a standalone execution layer. In the beginning, the consensus layer and the EVM were integrated together. After the merge, Ethereum client divided into two parts: the beacon node and the get, by using the engine API to decouple the two parts. So there's already have a decoupled EVM before, and Optimism replaced the EQ node with a OP node, which used the duration layer instead of the Sarmin chain consensus layer. So as we know, as a rollup chain, we don't need to generate block space. R2 is a special I1 DApp, and so as you can see, in the EVM, we can get a standalone execution layer, but on SVM side there's no. So why we need to decouple it? So here's the challenges. Sorry, it's to be updated. First is we need to build a duration pipeline which can derive R2 block. It's the main mechanism to generate a rollup block. Number two is to separate the SVM from consensus mechanism from Solana SVM, Solana consensus layer. So let's talk about the challenge one. We build a duration pipeline in Rust. We rewrite it and inspired by OP stack. Here you can see R1 block can derive multiple R2 blocks, and the soon node will subscribe all the deposit transaction and make sure it's packaged in the first duration layer 2 blocks. And together with the deposit transaction, the sequencer, the duration pipeline could also package the R2 payload. If you are a sequencer, the R2 payload typically come from the P2P network. If you are a validator, you need to derive the block from DA layer. The other challenge is that we need a standalone SVM execution layer. Fortunately, this year, Anza team writes a new SVM API, so we can use that. But as an execution layer, it's the only SVM executor. The engine is not enough. We need to decouple the executor and the storage layer, maybe the customize the P2P network. So here's the original Solana execution layer looks like. As you can see, they have the fetch stage, bunking stage, a broadcast stage, and they have a POH service which can prove timing for a sequencer. For a typical validator, there's Sarmin chain, no sequencer. And we introduce a soon engine API to decouple SVM. We abstract the R2 transaction format, block format, and the block payload, and we define how to generate a new block by using a standalone SVM execution layer, included storage, and how to deal with the block reorganization, the block finalization. So here is the new TPU workflow. TPU is the transaction process unit. It's a term we Solana said, but we simplify it to this. So currently we only have a SQL verification stage, bunking stage, and generate the entries and convert it to shreds which can persist or broadcast to other validator. And we open source education repo to show how decoupled SVM works. Yeah, here is the soon rollup architecture. As you can see, we have our soon node, and we replace the gas into soon SVM. It's a decoupled SVM. Yeah. Okay, Joanna.
Oh, sorry. Yeah, so just to recap, right, the three benefits of using decoupled SVM are first, efficiency to reduce the DA waste, and secondly is the security measures to, instead of having questionable multisig that are buggable, we can actually prove it with zero knowledge security. And then lastly is the performance, right? So we can improve the TPS and introducing this horizontal scaling solution. That, by the way, we're working with Anza. That's the dev shop that got spun out from the Solana network, and we're working with them to introduce this idea as a way to help other teams within the SVM world. So upstreaming our modifications on Agave back into the repo as a contribution. So yeah, so that's about us. Wanted to just showcase our the current Solana and Tom bridge as a first demonstration of that SaaS model, right? The super adoption stack. And this is actually pretty cool. Like you can now add these assets that are meme coins, Solana and Tom, and have that user flow between the two ecosystem. And some of these meme coins can now be traded on Jupiter and other dexes on Solana. So yeah, do give it a try and give us some feedback. To follow us, you can go to Twitter and just enter soon, SON, and underscore SVM. That's how you can get updates about us. Any questions? We're very efficient, I guess. That's our model, to be the most efficient rollup stack. Cool, thank you, appreciate it.